When it comes to safely taking on DIY electrical projects around your house, my recommendation for years now has been the WAGO 221 lever nut. This wire connector compared to standard wire nuts is just going to result in a more consistently secure wire connection in almost any application, especially those applications where you're bringing solid and stranded wires together. But there is another option. IDEAL makes the Ensure lever nut, which has a similar design, but I want to put it to the test. So let's jump into 3 different areas. First, we'll just compare and contrast the 2 different designs. Then we'll load up the designs and actually put 23 amps through the IDEAL Ensure connector and compare that to our past test to see how much it heats up. And then finally, we'll do a pull test with the lever closed. How much force can the Ensure actually hold compared to the WAGO lever nut? So let's jump into it. So first up, let's just look at the different types of WAGO and Ensure. 2 wire, 3 wire, and 5 wire, right, are going to be the same across each one. These can hold between 24 gauge and 12 gauge, which is going to be the same for the Ensure and the WAGO. What I do like about WAGO is you can get the 613, which is a larger lever nut. This is going to go up to 10 gauge wire, which comes in handy for some of your 240 volt circuits. And then the inline splice for the 2401, which again, for extending out wires and an electrical panel and some light fixtures, this can be really handy. So from a WAGO 221 standpoint, I do like the other types of connectors that you can get that go past your standard 2, 3, and 5 wire. Now let's do a close-up here on one of the critical features of these. WAGOs are so nice that they're pretty compact, especially in your 2 and your 3 wire. So if we say this is the overall length, very similar. If we say this is the overall width, very similar, where you're going to have a little bit of a differential here, let's get a good comparison, is the thickness. So it will not be as compact and you are going to give up a little bit more space if you're using the Ensure from IDEAL compared to the WAGO 221. From a basic operation standpoint, pretty similar, but there is a little bit of a difference. Now the WAGO 221 has a great housing, very easy to see the wire going within the housing, easily going past and making contact with your bus bar, and then you close that lever and you have a secure connection. Now with the Ensure, it looks like I have these upside down. Well, I do not. The levers are actually in the opposite direction. So we'd open up those levers and then we're going to go ahead and insert in our wire. You will be able to see that wire. It's a little harder to see. You're only going to see it right at the end. So you'd want to see the stripped and exposed copper all the way to the end. Then you'll go ahead and close that lever in the opposite direction and do the same for your second wire, making sure you see it all the way into that housing and then close it down. So you can see the levers are in the opposite direction for the Ensure. Now I believe that is to counteract possibly a design limitation or flaw from WAGO. So once you insert in wires, this is only 14 gauge, but you do have play in that lever. So because the spring is compressed here, there's a cam in here that no longer needs to engage. So that lever kind of is free. Now that is not going to impact much your holding force. It does impact it slightly, but the pull-out force is still going to be very strong with your WAGO. But the biggest thing is if you're pulling this connector out of a box with many other wires, it is feasible that that could hook on another wire when you're pulling it off, and then that could actually remove one of your wires and make for a bad connection. So I believe that is why IDEAL and the Ensure went with the levers in the opposite direction. And although the Ensure also will open up slightly, I do not think it would be as much of a concern as with the WAGO 221 lever nuts. Now overall, the housing is not as clear on the Ensure. You have a little bit clear housing on the bottom, but your sides are a little bit more opaque with the Ensure lever nut. Now a little closer look on the operation. There is a spring inside there, so when you press up that lever, you'll see that spring will start to press down, and then that opens up your passage here in the end, and then that is how we're able to pass that wire in all the way down across the bus bar. These are actually, you see the metal here, that's actually the bottom of your springs. Your bus bar is located all the way at the end. That is why with the Ensure, it's absolutely 100% critical that you get all the way to the end, because your bus bar is all the way to the end before you shut that. Now I think that is a little bit worse of a design compared to the WAGO lever nut, because our bus bar is actually in the middle. So it gives you a little bit more leeway. Even if you don't have your copper all the way to the end, you're gonna have a solid connection with that bus bar. So it gives you a little bit more forgiveness, even though you really do wanna bottom those off at the end of your lever nut. Okay, running two separate tests now. I'm gonna use the EcoFlow Delta Pro and the 30 amp RV outlet with a little conversion harness to be able to go above 20 amps. So I'm gonna run 2800 watts, so at 120 volts, that's about 23 amps with a variable heat gun here and then also a space heater. I've ran this load many times in the past, and that's why we're gonna be able to compare apples to apples. The Ensure from IDEAL, which is connected right now into the hot side of this outlet, we'll be able to compare 5-minute intervals for 20 minutes at 23 amps. How hot did that lever nut get? And then compare that to the WAGO 221 lever nut and a few others that we ran in the past. Then I'll jump right over to the pull test, do the pull test, and then we'll just sit down and compare the results to see how did the IDEAL stack up. So testing is complete. Let's jump into that. But first, let's also touch on price. Now, when it comes to the WAGO 221 lever nut and the IDEAL Ensure, they're about the same in price. The factor that's gonna drive your price up or down is more how many you're buying. So if you're just buying a 10-pack, you could be getting up to about 75 cents, maybe between the 70 and 80 cents range per connector. So they are a little expensive, but if you look right below this video in the description, you'll see a link to my Amazon store where I put all of my favorite tools for DIYers. Specifically in the electrical section, you'll see several examples of WAGO kits for your reference, and you can see the difference in pricing depending on how many you're buying. So there's 175 piece packages that are gonna drive that price even below 50 cents, more like to the 35 or 40 cents range. Or you can get the most common and popular kit, which is that 90 piece kit, because it comes with the inline splice as well. So between the two, I don't really think there is a price advantage one way or another. It's more gonna come down to where are you getting them and then what is that overall quantity that you're buying. Now for the loading test, we did those 4 different test points every 5 minutes. So it's 5 minutes, 10 minutes, 15 minutes, and 20 minutes. And now we're able to compare across many other connectors that we've tested in the past. So I plotted out the results here and we can see side by side. Starting off with the baseline, that is where no wire connector was in that circuit, going straight into the screw terminal, and then that was the lowest overall heat generated in our testing. Next up, the wire nut was the most efficient, that had the lowest amount of resistance and as such, the least amount of heat generation. The WAGO 221 lever nut is in gray. That is not doing too bad. It's a little bit ahead of the wire nut, but it is the lowest of any of the lever nuts we've tested. Interestingly here, a knockoff, which is an Amazon knockoff, a non-main brand knockoff, was actually lower than the IDEAL. The funny part about that knockoff number 1 is actually based off the IDEAL design, at least that's my take on it. And then the IDEAL came in a little bit higher, right? So we're about 10 to 11 degrees Fahrenheit higher at our 20-minute mark compared to the WAGO 221 lever nut. Now I will unhide a few columns here, and then that's gonna give us a few more data points. The thing we wanna look at here is there is a design specification of 221 degrees Fahrenheit for the IDEAL and the WAGO. So in both cases, the yellow line here for the IDEAL is well below the design specification, the maximum temperature that component should be able to function perfectly fine without exceeding. So there's no concerns there. But it also should be noted, one of the knockoffs that we tested last week was considerably higher. So really this is what I'm looking out for. A few degrees Fahrenheit here and there isn't as big of a deal to me, but when there's a separation like that we saw with this knockoff number 2, that makes me want to absolutely steer clear of any of those components when doing projects around my own house. So overall, Ideal is a little warmer, but I would not be too concerned knowing that the design specification is considerably higher than the ranges that we were seeing. And then there was the pull test. So actually applying force onto the wire to see how much force was needed to pull it out. Let me show the setup that we were dealing with, which is going to be the same setup we did with the WAGO 221 lever nut. So pretty simple testing setup here. I have a Works jaw horse, which is going to provide a stable platform for me to hang a adjustable weight kettlebell from a 3-wire, a WAGO 221 413, where I'm able to pass that wire through the jaw horse, set the 413 on top, and then apply all of that force through the middle slot on that WAGO, which I'll start at 20 pounds of force pulling down, and I'll increment up by 2.5 pounds until we get the wire to pull out, and then that will be our failure pull force in the standard condition. I'll repeat that for 3 different connectors, each time swapping out the connector to a fresh connector and also cutting back the copper so we don't have any damaged copper for each run. Now after those 3 intervals in the standard connection, we should get a consistent reading for the pullout force. So when we did the standard test with the WAGO 221, it held to 25 pounds. Did the same test for the Ideal and Sure lever nut, and the Ideal and Sure was actually considerably stronger. After doing, again, multiple iterations, cutting off new copper every time we got a failure, using a new Ensure lever nut every time we got a failure, we got all the way up to 35 pounds. So the Ensure did have a little bit more holding force when compared to the WAGO lever nut. So WAGO versus Ideal, after looking at the functionality, looking at some of the internals, doing the actual heat loading test, and then doing the pullout test, personally, my own opinion, I'm comfortable with either one of those. I think they're both great products, and I'd be comfortable using them for any of my projects within my home. Now, me personally, I'm gonna stick with WAGO. I've liked those products. I have a supply of those products here in my Milwaukee Packout, my little electrical setup. So I'm just gonna stay the course. I like the 600 series that goes up to 10 gauge. I like the inline splices for some of the electrical panel work, some of the light fixture works. So I think there's a few advantages to the WAGO, but again, I mean, if it's availability, you're running down to Home Depot or Lowe's, they have the Ideals. They're probably not gonna have the WAGO 221s. I get it, and I would pick up some myself. I have a few here from this testing that I'm sure I'll use on some projects. But let me know what you think. Give me some feedback down in the comments. Would you go with the WAGO or the Ideal, or you're not touching lever nuts? Lever nuts are ridiculous and you're gonna stick with wire nuts. All that feedback is welcome, and I really appreciate you guys giving me your take. Now, if you wanna just go back to some of the basics, maybe you're just starting to get into your electrical around the house, you're just doing some simple projects, maybe swapping out some light switches to some Decora light switches, maybe install the GFCI outlet, check out this video right here. It's a great starting point for what tools do you need, some basic wiring principles, and it just gets you started and gets you comfortable with some of the things you need to know before taking on electrical projects around your house. So thanks for joining me on this video, and we'll catch you on the next one. Take care.